Hi everyone, welcome. Today we're going to learn how we can download and extract time series climate data. In this case, we'll be looking at precipitation data. And once we are done with this analysis, you'll have the data something like this in CSV or Excel. It's monthly data. It starts from 1981 to the current year, 2023. So let's get started. So for this analysis, we'll be using Google Earth Engine cloud computing platform. So Earth Engine is a cloud API where you can, two things, right? Where you have a large volume of satellite data library, and also it provides analysis platform on the cloud. So you don't have to download the data. You can do the analysis on the cloud. So let's get started. If you're new to Earth Engine, you can type in Google Earth Engine. And then you go to Google Earth Engine, and then if you have an account, you skip this part. But if you are new, you can get started here, and then click to mostly use without cloud if you're new, and then you can sign up for Earth Engine and using your Gmail account. Once you have access to that, you can go to platform and then code editor. So code editor is the JavaScript API. Programming application interface where you can write JavaScript code and look at your analysis on the map canvas here. You can toggle between satellite and Google Map here, and this is some of the debugging tool to inspect the data and also just debug your errors. Just if you're new, in case to Earth Engine, let's just type in hello world and where's that? Okay, sorry. Print hello world. All right, so we can, if you're experienced to Earth Engine, just skip this part. But someone new, you can test this. You first code on the code editor, a JavaScript code editor, so you can print hello world here. So it's working. And so yeah, let's get started. So this data that we'll be looking at is a chirps climate data. You go to Earth Engine and datasets here, and then you can search for precipitation or just chirps. So we'll be using the chirps precipitation data, long-term climate data, which starts, as you can see, from 1981 to 23. So let's get started to the code editor, and I'll get rid of that. So first, let's import countries data, and var. Actually, let's start here. Extract monthly rainfall from chirps. Okay. So now let's just zoom this a little bit so that we can look at the code a little bit clearer here. So next step is to import countries database. Actually, you can get this from Earth Engine. So I usually use countries, and EE feature is a built-in Earth Engine feature to access geometry or polygon data. And I'll copy paste this data, which is currently on Earth Engine. So USDO's LSIB countries database, world countries database. If you really want that, you go to Earth Engine and go to dataset and LSIB. If you type in that, it should come. So yeah. So you can just simply copy paste that one. Okay. I've already done that, and so this imports a countries database for all countries around the world, so that you can just subset your country of interest, right? All right, let me just do typo here. Okay, next one is I'll filter the specific country. In this case, I'll be using Kenya as an example. So I'll create a region of interest, which is subsetting to one country instead of all countries. So countries filter, And EE filter, in Earth Engine you can filter data by name, then equal. So in this database you have a field called country NA, which provides a name for countries. And specifically you can change this to a different country if you're interested. For now, for this tutorial, I'll use Kenya. That way I'll be just focusing this analysis on Kenya. And I'll add this to my map canvas so that I'm just doing it right. Layer, so I'll add my ROI here. And I'll just name ROI or Kenya. And close the bracket. And the next one is a map center object. We'll adjust our zoom so that when we visualize the data, it will adjust our zoom to our steady area. So now I can execute this code. Something is wrong here, or just typo here. Okay, let's just execute that. The good thing about it is, just while you're here, this is a nice way that console just is kind of a debugging tool where you make some error here. It will just tell what specific line you're making error and whatnot. So countries, are we making error? Okay, that's why we're just not pulling the right variable. Okay, excellent. So now we have our steady region here. So what we're doing is we're summarizing climate data for time period starting from 1981 to the current year, and monthly times years for this steady area, in this case Kenya. Okay, you can change this in satellite and Google Map. For now it's fine. Okay, so next one is let's pull the data. Actually, before we do that, let's just create our lists of years and months, right? So because we're extracting a time series, let's just create the list, the temporal list here. So I'll create a list of years and months maybe. So what we do is just let's create a variable called years. Okay, and let's just create an Earth Engine list. Instead of writing all years, we can use a sequence, a built-in function in Earth Engine. So I'll use sequence. I'll use data from 1981 to 2023. Let's say 2022. Let's say, okay. And in addition, I also need to create a months list, right? So EE list. And again, the same sequence, and 12. So this will just create a list of years and also the months. That way we have to pull it programmatically. All right, next let's just import our rainfall data, which is I've shown you earlier here. The chirps data. You can copy this image collection ID here, so you can do that here. All right, so let's just create a variable called here rainfall image collection, and then just paste the image collection ID that you've pulled from the Earth Engine data catalog. Okay, and because this data set, this product contains multiple variables, we need to specifically specify precipitation. That way we're only downloading precipitation. So I'll apply select and precipitation here, precipitation. Okay, and that's it. And let's just close the bracket here, and let's just print what that data looks like just before we do any analysis. So print statement here. I'll print this image collection. Because it's a large time series data, instead of looking at everything, I'll look at the first image in the image collection. So that way I'll apply first, and then let's just print. Okay, let's just print and see what the data is. So we'll have all the image property metadata printed here. That's pretty handy for the first image. Okay, so the image collection ID is here. So that's the image collection ID we've used here. And the different band list is because we have selected, you know, precipitation. We have the exact precipitation data here, you know, data type and dimension, whatnot, if you're interested on that one. And another thing is that this data has, you know, already a month and a year. So, and also the month-year combination here, system index. Okay. Okay, so the next thing is let's just create an image collection mapping over years and create a monthly, you know, total collection, right? So map over the years and create a monthly totals collection. So I've already written this function, so I'll just copy paste here. And so what I'm doing here is, let me explain this code. So what this function does is, so it pulls the years here, the years, you know, all the years list here, and then maps it over the image collection, in this case rainfall here, right? So we're just calling this rainfall image collection. So maps it over, you know, year and also months, right? So and also filters it by, you know, year and month. So those 2 bits of code will specify the, you know, the timestamp. And at the monthly level, we're just doing you know, sum. We need total total rainfall, total monthly rainfall technically. And then last thing is just it will return this data, but then it will have timestamps, you know, months and year timestamp. Okay, that's what this is doing. It will take this image collection, it will calculate the monthly sum for each you know, timestamp, and generates an image for each month, a total rainfall for each month and year. Okay, and then we have not mapped the, you know, this to the so this is not yet an image collection. So to do that, what we do is we just pull, you know, that we create a variable called monthly and call, and then what we do is just we apply image collection from image to generate a real image, right? So that will kind of convert this list to a real image collection. Image collection function from image. That's an Earth Engine built-in function. Okay, and then I'll copy paste this function here, which generates all right, and then let's just print that this newly created collection, image collection, it's kind of ready to go now to be extracted and exported. Instead of doing all image, because it's a long time series, let's just do the first image as always to save for, you know, competition. Even though we're using cloud, you know, Google Cloud Computing, parallel computing, sometimes you can get maxed out on your quota, so you have to be careful in terms of printing, especially printing, you know, image. So just you better do, like, if it's a collection, I recommend doing it the image collection dot first. That will minimize, that will, you know, save you from being maxing out your quota on Google Cloud. All right, so just we have pretty neat, right? So we have the months, we have, you know, the system index, and also the year. That's pretty neat. And also the, you know, precipitation variable. So now this is ready to go to be, you know, downloaded. Okay. So the next thing is, let's just do the zonal statistics. That's the fun part. So let's just do the zonal statistics. What we do is, so far what we've done is we have created our region of interest, the polygon. You can change this to anything. We've created a list of years and image. We have imported the image collection, and then we've created a function that creates a total monthly image for each month and year. That way we have a total rainfall for each month from 1981 to 2022. And then we have converted that list to an image collection by applying image collection dot from image. Now the next main part is, because, you know, mind you, we're creating a climate time series and then export it to a CSV or Excel sheet, right? So that we can use it in our research or analysis or, you know, presentation or report, right? So let's do zonal statistics. So zonal statistics is summarizing data using a polygon or shapefile and an image for that specific region of interest, and using various summaries, including, you know, mean or, you know, max, what have you. So let's I've already written that function. Just copy paste that in, you know, for the sake of time here, and I'll explain that code. So this is a zonal stats code. Zonal stats. To summarize, I'll just rename it rainfall. Okay. And that's about it. So what the code does is, you have this image collection, right? It's already created this image collection, and what this code does is just it maps a function, creates a, you know, an image. So for every image, so creates a feature which is a region of interest here. It's Kenya, right? Or just polygon here. We'll pull that here, and what it does is just, you know, two things: pulls the image collection, pulls the feature, and extract the month and year timestamp from the image, and assign it to that specific feature, in this case the region of interest. And because sometimes you create some error if you don't define a projection, so you pull that projection information from the image collection. What this does is just creates a projection file. This is our image because we're using the first image in the image collection, so it will extract the projection information from that image, and this way our project will be used here in the zonal statistics. So the main function here is, here returns an image for each monthly image. What it does is reduce regions. This is a zonal statistics algorithm, Arzingen built-in algorithm. That's what gives you the zonal statistics analysis. And based on a feature, in this case, our feature, which is what? This Kenya, right? The polygon. And then EE reducer mean. So we'll just calculate the mean over the entire, you know, region, in this case Kenya, for each month, generate a total monthly you know, value. So this mean is not for each month, rather it's just across our study area, right? So spatial mean rather. And then you define a scale. In this case, we'll do you know, 1,000 meter. You can change this if you want to. And that's it. So this function will generate a zonal summary. So for summarize or generates, you know, a CSV you know, file. And let's look at that. I like printing you know, stab before I export. I just look at them and explore what's going on if there's any issue. So let's print this print rainfall summary mean. And I'll just copy paste this guy here, which is the zonal stats. And because that's a large, a CSV file, I'll apply limit. That way Earth Engine will not max me out, because you have a specific quota. Even though you're using tens of thousands of Google's computer, you have a specific quota. If you're just over that, you'll be, maxed out and running out of memory, and then you have to wait like some time, sometimes hours, sometimes, so it may be longer. Okay, so let's just do that. Let's print. Now we have our zonal stat analysis function done. Let's just go ahead and execute that. Let's see if it's working. So it's computing now. It's done. We have defined limiter 10, so we have about 10 data points. Let's see our extraction. Excellent. So this is our table. Then the last part is just exporting, but let's look at it. So we have our year, and we have months, and we have the zonal stat summary here. And then just because we're using Kenya here, that's our polygon. So excellent. That's great. So the next part is just actually to export this data. All right. So let's just write a function that does export this. So export the resulting mean as a table or CSV file to Google Drive, right? All right. Actually, before that, let me just create a variable, because if you just simply export this, you'll have a pretty long and clumsy table which has lots of data set, including lat long and whatnot. It's not pleasant. So I usually like to do selectors. That way I'll specifically select only the attributes or the fields that I need to export. The others I'll disregard it. This selector approach does that. So selectors, create a variable, and then I'll define the variables that I'm interested to export. Country NA is just the country name. I don't necessarily need that, but just let's do that here. In this case, it's Kenya, right? Okay, the last piece is export table to drive function. To drive, and a curly bracket here. And okay, what do we have? Collection. And I'll copy the zonal stat summary table here. That's our collection here. That's what we want to export. And a description. Technically, this is the folder that you see it on your Google Drive once it's done downloading. Rainfall times years. And a Google folder name prefix. All right, so this is your Google folder. I'll actually usually like to give the same name for description and Google folder. And the last piece, actually the next piece is a file format. In this case, we want to export this as CSV file, right? So file format. Alt CSV, so more like an Excel, similar to an Excel table. And the final one is selectors. You see, I've created a selectors, right? So I'll just need to apply that in my export, so that I'll only export this fields. Okay, I think that's it. And let's just close our JavaScript using a semicolon as always. All right, let's just execute this. And unexpected error. What's going on here? All right, so export. Let's see. We're making some error here. Let's see. All right, collection, description. What is the error here? Export table to drive. What else? Okay. Folder name prefix. Okay. It's a typo. File name. Alright, it's instead of folder name, it's file name. Okay, that's what it is. That's nice. So good debugging, right? So instead of a folder name, you just see file name prefix and file format. Alright, let's just execute that. Alright, it's computing. So once this is running, it's your analysis is running on the Google Cloud API, and just I'll go ahead and run this and just run that. And if you go to your Google Drive, you'll see your exported table. Okay, so you can see rainfall time series here. This is your rainfall time series. You see the country is Kenya, that's right. And it starts from 1981. You have a month, you have year, and you have your total rainfall. So this is not necessarily, we can change this name, but it's, don't be confused. This is sum total. What we do is just the mean over the entire polygon. Otherwise, it's a monthly total rainfall. Let's just go ahead and download that. Excellent. So when we download that, this is what we're looking at. So you can plot, you have your year, your months, and your mean. I've already done this, earlier, so you can add, the Kenya country name if you want to, but otherwise it should be fine. So yeah, you can plot this, and you can do some seasonality analysis. You can do trend analysis, and you can generate plots, and you can do some analysis for a publication. So this is how you apply the Google Earth Engine Cloud API to process a long-term climate data for any place using the CHIRP's precipitation data.